I will present about introduction regarding our project HVDC wet and dry test. Okay, first is in constructing a DC tower system, insulator must be made to have enough strength to support the weight of conductor bundles and other additional loads. The second one is one need to have a sufficient knowledge on the insulator design, the application of protection equipment, formulate size and length, estimation of performance and installation. Okay, the last one is in this project, after the insulator has been designed based on a standard electrical profile of material and type of insulator, the simulation must be done into condition which is contaminate and without contaminate before high voltage testing is done. This case can be done under dry and wet condition. Okay, next is problem statement. Overhead power line insulator that have been designed consists of suspension insulator for use on suspension tower. Initially, the overhead power line application used the cap and pin types. It must be designed based on insulator prototype property option, that is 132 kV plus material types. The maximum length must be 1540 mm and 175 mm square. Stack and fitting option of cap and pin. Okay, all of the properties must be designed using SketchUp and then imported the sketch from the SketchUp to the final element analysis. This simulation software, that is a console multiphysics 5.5. After the simulation is done, safety risk assessment and code conduct must be ensured for HVDC dry and wet testing to conduct. Okay, next is objective. There are three objectives for this project. First is to design and simulate the insulator purpose in console modeling software. Second is to analyze the performance of the insulator purpose toward the electrical stress. Second is to propose a suitable high voltage laboratory test setup. Okay, next is a scope. Scope of the project, there are three. First is a glass insulator with the maximum length of 1540 mm. The creepage clearance must be 4200 mm and 175 mm squared. Okay, all of this will be designed using AutoCAD software. Okay, second is to analyze the performance of the insulator. We might use the console software 5.0. And the last one is the prototype will be done and will be tested as HV, dry and wet test in UTHM laboratory, which will have a brief of safety risk assessment and code conducts. Okay. Outcome of the work of this project is the simulation result with respect to the different scenario and technique of simulation will be categorized and generalized to ensure it can prevent current flow through it out across its surface under the dry and wet condition and have enough strength to support the weight of conduct bundle load in order to cater the user with optimum performance. Okay, that's all for me. Thank you.
Assalamualaikum. So I will explain about the summary of concept design, okay, that we have proposed in our preliminary work. So for our insulator parameter, okay, the system voltage is 132 with load voltage of 175 millimeter squared, triple AC weight 659 gram with breaking load of 67.09 kilonewton, and our material is glass. The type is string insulator and fitting option in cap and pin. And this is the very important part, which is the location is very heavy polluted location, which is the number 4 in according to IEC. So this is our cross sectional of one insulator disc. Okay, this is our insulator string. So inside that, this is this is the same like this. Okay, this is the cross sectional. So the material properties is very important in determining. Okay, so this the type of material that we use is glass. The cement growth, which is this is the cement growth. Okay, the air and contamination. Okay, which include the rain. Okay, chemical substance because our location in heavy polluted area and still hot deep galvanized. Okay, in by using the arcing horn and gut ring. Okay, the mechanical property, okay, and electrical property actually. Okay, but I want to highlight which is the diameter, which is of the insulator, which is 175 millimeter, the spacing and nominal creepage distance 190. This is we calculate according to the IEC, okay, that suggested the heavily there is a calculation for calculating the minimum clearance distance. So the other property is we added the arcing horn and grinding ring, okay, to avoid the flashover, the number of glass and insulated cap pin. So we use by rule of thumb, one insulator can withstand 11. So it need a number of glass is needed to make the 12. So 11 times 12 is we get the 132 kilovolt. So the advantages, the cap and pin, okay, it has the high mechanical capability even with shell damage. Okay, the simple and most favorable design of each unit, high impact and bending capability of the insulator string. And the disadvantages is the high electric stressing of the insulating material and corrosing, numerous fitting, high weight of insulator set, high maintenance cost, and arcing horn and guard ring. It can protect the insulator from power arc with temperature ranging up to 12K, but it's not favorable in the utility, okay, because the pollution is not severe and the duration of short circuit is too short, or the power not high enough to cause failure. It can increase the probability of flashover.
So I will explain about the technical summary of finite element analysis FEA simulation software. So the function of finite element analysis FEA simulation software for this project is to design, calculate, and analyze electrical stress performance in terms of high voltage and electrical fields. The project was carried out by the Console Multiphysics 5.5 simulation software. It is a powerful interactive for modeling and solving all kinds of scientific and engineering problems based on partial differential equation, or we call it PDE. The models can be built by keying or define parameters for physical quantities, such as loads, constraints, and material properties. These variables, expression or numbers, can be applied directly to boundaries, edge, solid domains, and points of computational mesh. The process when using Console Multiphysics 5.5 involves three processes, which are pre-processes, solving, and post-process. For the pre-process, all the parameters of physical quantities need to be defined according to the material characteristics of the prototype that needed to be tested. For the solving process, the boundaries of each geometric condition are applied and all the problems will be solved based on PDEs. For the post-process, the result will be shown and the plot is generated by simulation in terms of variables and parameters. In this project, an insulator made of the glass metal is considered for the simulation dimension of the 132 kV insulation. The insulators will be examined in terms of electrical potential in two different surface conditions, which are in contamination and without contamination condition. So this is a process flow FEA simulation on the prototype. So for the starting, first we have to determine the type of insulator, and then we have to create 2D geometry. Then we have to define models, material properties, and boundary conditions. After that, the model must be meshed. Then we have to make sure that the post-processing result is shown. If not, we have to redo everything from the first step, which is create the 2D geometry until the mesh model, and we have to make sure that the post-processing result is shown. If yes, we have to record and analyze the data. So I explained about the technical summary methodology of FEA simulation on the prototype. So there are procedures and processes to simulate the prototype or insulators to ensure there are accurate data and result can be recorded. First, our group have to determine the type of insulator that needed to be tested. So we have to do research and study in material characteristic before determining the type of insulator. In this project, 132 kV system voltage glass string with a cap and pin insulator on industrial polluted areas is our focus. The load for this study is 175 mm² AACC that has a weight of 659 meter. For the material properties, based on the glass material, the values of relative electric permittivity is 4.2 and the values of electric conductivity is 0. The standard and data profile of glass string insulator also must be studied. Then we had to build a geometry.
The insulator that we choose is the prototype that we are going to simulate in COMSOL Multiphysics 5.5. It can be in Cartesian or cylindrical, and it also can be in 1 dimension, 2 dimension, or 3 dimension. For our group, we sketched the insulator in 2D by using SketchUp and imported in the console using software. After that, we had to define models, material properties, and boundary conditions. We have to indicate which partial differential equation should be solved. For electrical field and high voltage, the simulation software used the Poisson equation to solve the problem. We also had to define the material properties such as relative electric permittivity or electrical conductivity. For the boundary condition, it is essential to define the specific voltage or charge at the boundary. Next step is the mesh model. Meshing the model is a numerical way to solve partial differential equation. The process is when the geometry breaks into small pieces that are called elements. It can be assumed linear behavior, and each one of the pieces can transform entire things into the system of linear equation and expressed by the matrix, and can be solved by the software to find the best approximate solution to that system equation. Essentially, by meshing the model, it is transforming it into a system of linear equation and can solve the electrical problems. The final mesh is the best to get a more accurate result, but needs more computation time. Lastly, the result will be shown in the surface plot of the electrical potential. You also can do arrow plots for electrical fields and streamliners to show the paths of particles in electrical fields. If the post-processing does not show the result, troubleshooting of the problem must be done. The process must be redo starting from the first process, which is build the geometry, until the result of simulation can be achieved. If the result of the post-processing is shown, the data can be recorded and analyzed.
So I will explain my part, which is the result and analysis of our FEA work. So this is our insulator disc, which is per unit. Okay, our cap and pin glass insulator. And this is our string insulator, which is the attachment of several insulator discs. Okay, and as you can see, the bottom line is our high potential, electric potential, which is the carrying the system voltage, and the upper part is low potential, or we can say a ground that is connected to the tower. The first case, we observe the single insulator. So as you can see, the electric potential distribution contour right here, we can see that the electric potential is much more higher at the steel pin. And for our electric field distribution, okay, we can see that the equipotential line is much more narrower to the steel pin, and as you can see, the gradient color is changing in the steel pin. Okay, the second case, we observe the contaminated insulator, okay, which is caused by a various factor. It will be a wet condition due to rain or other chemical substance, because our situation or our place that located in a highly industrial polluted area, and we have set up our relative permittivity, which is Ct1, and electric conductivity is 10 to the power of -4 Siemens per meter. And for our clean insulator, we assume that the insulator is placed, okay, in the wet condition, and there is no pollution occur in that places. And as you can see, the grading color of grading color of electric potential between the clean and contaminated. Okay, from my point of view, I didn't see a very big difference between these. So I plot it in the line graph. Okay, and I observe that the pattern of the graph is non-uniform, and there is slight changes, okay, in the beginning of the line graph. And as you can see, if we see the maximum voltage of the contaminated contaminated insulator is much more higher than a clean insulator. And as you can see, the electric field distribution, okay, the clean insulator is much more narrower, like a single insulator, but the contaminated, okay, we can see that, okay, the equipotential line is much more decreased. As you can see, the color grading is slightly different from the clean insulator. And if you plot it in the graph, okay, by a distance measure from the HV electric plot, which is the bottom, to the upper, okay, you can see that, okay, the contaminated insulator, okay, maximum electric field is much more higher. But if you see the pattern of the graph, okay, the contaminated has less number of pattern, okay, compared to the clean insulator. Okay, now we're adding a arcing horn and guard ring. So what is arcing horn and guard ring? Okay, which is the arcing horn and guard ring is to protect from the flashover. Okay, the one thing that I forgot to explain in the clean without the arcing horn is the mesh model. Okay, in this arcing horn and guard ring model, we are using an extremely fine mesh model, which is can increase our precision of the result. Okay, and for the electric potential distribution, okay, it's same as the without the arcing horn. Okay, it doesn't have for the contour. Okay, it doesn't have a very much big different. But if we plot it in the graph, okay, we can see that the contaminated insulator maximum voltage is much more higher than a clean insulator maximum voltage. And as you can see, if we can see a difference in the without the arcing horn, but for the electric field with arcing horn, we doesn't see a much big difference between the contour of the electric field distribution. But if we plot it, okay, we can see that the clean insulator has a higher maximum electric field. And as I told you earlier, that the pattern of the clean insulator is much more higher than the pattern of the contaminated insulator. Okay, so the last thing that I want to observe, to analyze, that the electric potential doesn't have a much more different, because when we design the insulator, we have calculated that the creepage distance for this insulator can withstand the highly polluted area. So that's why the maximum voltage is not have a much more different, as same for the electric field distribution. So,
and I would like to talk about the code of conduct and also the conclusion for the high voltage testing proposal. So for our testing on the glass insulator, we are doing the dry and wet test using the high voltage direct current test. So this is the circuit diagram for the high voltage direct current test, and this is the place to place our glass insulator to be tested. So the dry and wet test is quite simple. For the dry test, we need to only apply the direct current voltage to the insulator and raise the voltage until the flashover occur. So, and then the voltage is recorded. Okay, for the wet test, the insulator is sprayed with artificial rain drawn from the nozzles. As you can see, this is the detail of the artificial rains, which is 3 mm per minute. The resistivity of the water is 100 ohm plus minus 10%. The angle of the rainfall is 45 degree, and the temperature of the artificial rainfall is 30 degrees Celsius. And the same as the dry test, the DC voltage is applied to the insulator and then raised until the flashover occur. And then the voltage is recorded 5 times. So for each of these tests, first we are doing dry test and then repeat it for 5 times, and also then we are doing the wet test and repeat it for 5 times to get the average value of the flashover voltage. The value of the flashover voltage is measured through a resistive potential divider. So for the precaution that we must take during the test is all equipment must be able to withstand the overvoltage risk, because to avoid any overheating of the equipment that can cause fire hazard. The next one is the proper guarding must be done to avoid any danger to the tester, which is human, so that no electric shock occur. Safety equipment must also be used to further minimize the risk of being electric shock. The last one is the adequate clearance for the conductor to all insulated structure must be more than 1.5 times the length of the insulator direct arcing distance. This is to avoid any flashover occur between the conductor and the insulator, and between conductor, insulator, and other equipment. So for the conclusion of the high voltage proposal, the proposed test should be able to show the withstand capability of the insulator by knowing how high the flashover voltage can go. So the higher the flashover voltage would be the higher the withstand capability of the insulator to the overvoltage. And the next one is the test to be done with proper precaution, as working with high voltage can cause severe damage to equipment and especially to human, which can cause
human to have lifetime damage or fatality. Okay, that's all from me. Thank you.